we're now going to have a look at an example that involves manipulating logarithms and solving logarithmic equations. So here, part A says, given that log to the base A of x equals p and log to the base A of y equals q, express the following in terms of p and q. So this question is all about splitting up logarithms using the 3 logarithms rule, which on every question you do, you should write down in order to remember them. So log A plus log B equals log of AB. Log A minus log B equals log of A over B, and then log of A to the B equals B log A. So we should write those every time. So part 1 says write the following in terms of p and q. Log to the base A of xy. We're splitting that up using the addition rule. 2 things times together. I can rewrite that as log to the base A of x plus log to the base A of y. Well, log to the base A of x we've defined as being p in this question at the top there, plus, and log to the base A of y is q, so that can be written as p plus q. Part 2. Okay, so splitting this up now, we can see there's a division there, so we can use the subtraction rule on this. So the numerator, log to the base A of a squared x squared, take log to the base A of y. Splitting this up further using the addition rule, log to the base A of a squared plus log to the base A of x squared minus log to the base A of y, which is equal to, well, log to the base A of a squared, this is what power do we have to give A to get a squared? Well, clearly we give it a power of 2 to get a squared, so that just becomes 2, plus, using the power rule, we'll bring the 2 to the front, 2 log to the base A of x, take log to the base A of y, and we're ready to make the substitution that the question asked for. So it said log to the base A of x is p, so it equals 2 plus 2p, take, and log to the base A of y was defined in this question to be q. So there we go. Part B, solving a logarithmic equation. Express log to the base 10 of x squared minus 10. Take log to the base 10 of x as a single logarithm. Well, we're going to use the subtraction rule to combine those. So that can become log to the base 10 of x squared minus 10 over x. So we've used the subtraction rule for logarithms, which we wrote down earlier. There it is there. When we subtract 2 logarithms, we can divide their contents. Okay, so then it says hence solve the equation. Well, the reason it's got us to do that is because we can only really solve logarithmic equations when the logarithms are neatly bundled up into a single term. So writing this out, we've got log to the base 10 of x squared minus 10 over x equals 2 log to the base 10 of 3. Now the left hand side is neatly bundled up into a single logarithm. That's good for solving. If it was in the previous form, we couldn't just unlog both sides. Here though, we've got a problem because it didn't just say log to the base 10 of 3, so we're not ready to unlog it yet. It says 2 log to the base 10 of 3. We're going to need to use the power rule to get that 2 back in there. So using the power rule, log to the base 10 of x squared minus 10 over x equals log to the base 10 of 3 to the power of 2, which is log to the base 10 of 9. So now we've got a nice equation here which is ready to unlog. Log to the base 10 of x squared minus 10 over x equals log to the base 10 of 9. Now how do we unlog? Well, the opposite of log base 10ing something is 10ing it, if such a term exists, raising it as a power of 10. So between this line here and this line here, we're going to do 10 to the power of each side. So 10 to the power of log to the base 10 of x squared minus 10 over x equals 10 to the power of log to the base 10 of 9. Now what this says is log to the base 10 of x squared minus 10 over x says what power do we have to give 10 to get x squared minus 10 over x? Well, whatever it is, we then give 10 that power to get x squared minus 10 over x. So what power do we give 10 to get that? Then actually giving 10 that power, we get that. So this 10 and the log to the base 10 sort of cancel each other out. Same argument goes here. So equals 9. Multiplying by x, this means that x squared minus 10 equals 9x. Then rearranging the quadratic, we get x squared minus 9x minus 10 equals 0. And we can factorise that if we want, but we're not going to. We're going to speed things up by using the calculator, so putting it in equation mode, polynomial degree 2, so 1x squared minus 9, oh, I've accidentally put it in simultaneous equation mode, polynomial degree 2, 1x squared, take 9x, take 10, equals, so the first one is 10, x equals 10, and the second root, if I press equals again, is minus 1. But that's not the end of the story, because now we've got to think in the context of this question, which one of those solutions makes sense. So reading it, we've got log to the base 10 of x squared minus 10 minus log to the base 10 of x equals 2 log to the base 10 of 3. Now in theory both those solutions should work. However, looking at this one here, minus 1, if we try and sub that into the log to the base 10 of x term, log to the base 10 of minus 1, let's try and do that. So log to the base 10 of minus 1, we get a maths error. That's because logarithms can't be taken of negative numbers. Therefore this one is an invalid solution. There's only one valid solution, x equals 10. And there's the question done. For more videos like this, go to alevelmathsrevision.com or subscribe to our YouTube channel.